So here's a quotient rule problem. Just want to remind you first that the quotient rule is d dx of f of x over g of x is equal to g of x times f prime at x minus f of x times g prime at x over the quantity g of x squared. This is really important, Ryan, because if we do this backwards, it kind of matters. With the product rule, if we do the whole pieces backwards, 3 plus 5 is the same as 5 plus 3. So it doesn't matter. We have the commutative property of addition. But it doesn't matter here. So order matters here. So it's g of x, f prime at x first. Okay? So here, we're going to find the derivative of y equals 5x minus 2 over x squared plus 1. And the derivative, d dx, of 5x minus 2 over x squared plus 1 is equal to this mess. The question is, how did I get that? I knew that I was going to use this quotient rule. And I knew that I was going to build a list. So I'm just building my list here. I need to fill in the blanks on this top piece up here, Dylan. So what I'm going to do is this. Say f of x is the top part here, so it's 5x minus 2. The first derivative of 5x minus 2 is, okay? The bottom piece, g of x, is this piece here, x squared plus 1. So there it is, g of x is that. And the first derivative of x squared plus 1, Chloe, is 2x, right? So all I'm doing here is filling in these blanks. This is this, this is this, this is this, this is this, and you can check it from this list also. And anytime you can just pause this and take a quick look at it. So I'm going to have all my pieces there, and then I'm going to simplify a little bit. Multiply this out, 5x squared plus 5, 5x squared plus 5 here. And I'm going to distribute here, and then I'm going to distribute this negative sign. This negative sign was this one. So a negative, this was a positive, is a negative. This was a negative, so this is a positive. So far so good. And it looks to me like this is our derivative. It's actually not that bad, is it? Yep. Yeah, it doesn't matter where you distribute this negative sign. It's a really good question. You can distribute the negative sign right here, and then when you distribute this 2x, do you know what I mean? It's one way or the other. I usually wait till the end because I'm reminding myself that this is a quantity, that I'm taking this whole thing out of here. But it doesn't matter which way you do it. Again, commutative property of multiplication. So it doesn't matter what order you multiply things in. But you wouldn't want to. You certainly want to multiply it times this and then times that, because then you're distributing multiplication. You're distributing multiplication over multiplication, which is not possible, is it? You see what I'm saying? Okay. So I think this is our answer here. And of course, we have to go check. So let's check this, and then we'll come back and see where we are, okay? So you have your CAS calculator out. Why isn't my calculator on? So from the pull-down menu on your CAS, if you would, I am going to go to, what just happened? Oh, here it is. Wow, that's good. Calculator, we're going to take a derivative here, aren't we? And it is dy dx. And the equation was a rational equation, so it's control division. And what was it, 5x minus 2? 5x minus 2 over x squared plus 1. X squared plus 1. See, I didn't actually have to put in the second set of parentheses here because I wasn't going to raise this thing to a power. If you do it otherwise, sometimes it does something weird here. So as long as you use even numbers of parentheses, use the number of parentheses that you need. Is that the right answer? Yeah? Yeah, yes? And what did they do here? They factored out a -1, is that what they did? Okay, cool. All right, so hopefully that's good. Let's turn this off and we'll go back to work. Stop.